For this part of the lecture set, we'll be talking some more about the three types of claims, along with what types of validity to use to evaluate how good or effective or sound these claims are. So to start, validity refers to the appropriateness of a conclusion or a decision. How valid is it? Please be aware that this is not the same thing as reliability. Oftentimes reliability and validity get talked about together, but they are not the same thing. For example, a scale that you could use to weigh yourself, and let's assume that it was always off by 15 pounds, either 15 pounds too heavy or too light. A scale that is always off by a fixed amount is, technically speaking, reliable because it always gives you the same result when you stand on it, assuming your weight stays the same, but it is not valid because it's not the actual weight that you yourself weigh when you are standing on said scale. Now, studies and findings can be reliable but not valid in the case of the scale just mentioned, but it is not possible for them to be valid and not reliable. Because if something is valid, it is coming to the appropriate conclusions, thus it is accurately reflecting the world at large, and therefore it should have reliable findings. Otherwise, what you're studying is not actually, or it's unlikely to be, an accurate representation of the world at large. Now, when it comes to types of validities, you will hear these four talked about a lot. They won't always be talked about in the same name structure. A lot of that depends on the author who is writing about them. Additionally, you will see places, especially if you go on into further methodological courses, where even more validities are talked about, or more specifically, extra nuance is added to these four general categories. So to start with, we have construct validity, and this refers to the extent with which a measure captures all parts of a defined concept. So what we mean by this is if you were to take a personality trait questionnaire that measured how extroverted you were and how agreeable you were and how conscientious you were and how neurotic you were, so on and so forth, a metric or measure of construct validity in this case would be how accurately that questionnaire set that you just filled out actually reflects your personality traits. How well does it capture them? But not only that, does it in fact capture all the qualities and traits of what we currently define as extroversion? So for example, in that subclass of extroversion, if you were only asking about how likely they are to be the first one on a dance floor or something like this, then yes, that sort of fits with our ideas of extroversion. But when we're talking about extroversion, there's also this quality of being able to interact openly with other people, enjoying spending time with other people, and just asking about a dance floor does not allow us to find out about how gregarious they are, for example. So the two really important things to keep in mind in construct validity are not only how well is a measure reflecting something in the world, but also does that measure capture all of the parts of the phenomena that we think it is supposed to capture. All of these things fall under construct validity. Following this, there's statistical validity, and this is the extent to which any kind of statistical conclusions that are derived from a study or a set of data are accurate and reasonable. And some things to keep in mind whenever thinking about any of the statistics that you will come across in research is the margin of error, statistical significance, and then effect size. So working through these, margin of error just refers to the error that is inherent in any type of statistic. What we mean by a statistic is anytime you calculate some metric that is an estimation of the population at large. For example, if I was to measure the height of every person who is currently taking this class, and we come out to an average height, let's say after taking the mean of 5'8", and then we say, okay, all people now are with an average of 5'8". And that actually might be a reasonable, accurate estimation because there's almost 200 people across the two research methods classes. That being said, even if it is fairly accurate, it will always have some degree of error. Now, even if we were to measure the majority of all people on Earth, until that point where we measured every single human being when we're looking at their height, there would always be some error in that statistic that we derive from that information. Now, different systems, different measurements, different phenomena, different ultimately fields of study will all have different amounts of error that are associated with the statistics that they tend to use. So, for example, if I am measuring, let's say, the tolerances of transistor size on circuit boards, the margin of error is going to be relatively small just by nature of how tiny those transistors are. Whereas in using the example of the heights of human beings, it will have a larger margin of error than for the transistors. Does that make it bad or more incorrect in reflecting the world? Not necessarily, because it also depends so much on what is the thing we're measuring. For example, if we were looking at the height or weight of human beings and comparing it to the error that we might find in the diameter and weights of planetary bodies, the errors are going to be much larger for planetary bodies, but that doesn't necessarily make it worse because of what you're measuring. That being said, the higher the error in any type of measurement, the more difficult it is to make accurate predictions and to make sound conclusions from it. Following this, we have statistical significance, which is oftentimes evaluated using p-values or probability values. The sort of rule that exists across psychology is this p less than 0.05 business, where if you see a probability value of your study being less than 0.05, it means it's significant. People get happy because you can publish things. And if it is greater than 0.05, then people are sad and they either engage in questionable research practices or they just do some other studies, which would be the better way to go about this. Or technically you would just report it, because in all honesty, having information about what doesn't work is oftentimes just as important as information about what does, but that is a different discussion. Now, when dealing with statistical significance, instead of getting stuck in this heuristic of under 0.05 good, over 0.05 bad, it's important to understand what that 0.05, or the p-value even better, actually means. When we're talking about p-values, what we're actually talking about is an assumption that if there was no true effect, how likely are we to see the data that we have in front of us? So when you get a p-value of exactly 0.05, what you're saying is, if there is no effect out in the world, if my assumption is wrong, what it is that I'm trying to prove is not the case actually, then that p-value of 0.05 implies that every 1 out of 20 times I repeat that same study, I will have data that looks like mine. So we use this 0.5 criteria just as a set of balance, but the smaller a p-value is, does not mean that your findings are somehow now more true. All that indexes is how rare your data is under the assumption that there was no effect. So for example, if I wanted to look at the impact of caffeine on response times in a reaction time study, I could, let's say, give a group caffeine and another group decaf, make them do their reaction times, and I saw that the people who drank caffeine were actually in fact faster than those who did not, and the p-value was 0.01. What I'm saying now is that there is a 1 in 100 chance to see the difference across both of those groups if coffee had no effect on people's performance. Thus, it would be very rare to see that data, and so the way null hypothesis testing works is we say because that is below the threshold of rareness, we will therefore conclude that caffeine has some effect. So it's very important to sort of keep that nuance in mind, because it will help a lot with your ultimately interpretation of other people's work, and it will prevent you from making similar types of errors. Along the same vein is effect size. Effect size is a very important way of establishing how large some phenomena is, or how small or how strong a relationship is. And this tends to be sort of separable from p-values or proportion values. And it allows us to sort of compare across multiple studies, even if they're not done identically. So being able to look for this is also a good way to establish whether something is just significant due to a large number of people or individuals thrown at it as opposed to actual significance. The effect size will be less biased by problems that p-values have and can oftentimes be used to index the magnitude of a relationship. That being said, effect sizes do not give us an index of rarity, and thus they are not used directly in null hypothesis testing. But both are reported more and more nowadays in modern literature. Moving on to external validity, this is an indication of how well the results of a particular study generalize to or represent individuals or contexts other than those in which the specific study itself was conducted. So there are many ways in which this can be applied. One of the most talked about is in cross-cultural literature, where if I do a specific set of studies on European Americans, will that same phenomena show up if I now move to Japan and repeat the same study, or if I move to South Africa or to Chile or to Greenland for that matter? Now, in all of these cases, if something has very high external validity, it will show a similar pattern as I move it through different contexts. Now, you don't need to go to different cultures. For example, it could be that you're just looking at a study that happened to only examine people who identified as female. There's no guarantee, even though it might seem like it, that that will be the same for all individuals who identify as male or who identify as non-binary. Now, some things travel across these types of contexts very easily, and other things do not. But oftentimes, until we have actually done the work, there's no way to know for sure. So something that gets talked about much more nowadays, even though maybe not enough, is this idea of weird participants in psychology. And we don't mean weird in this sense as just strange psychology people, even though that stereotype exists as well. In this case, WEIRD is an acronym for Western Educated, Industrialized, Rich, and Democratic. And what this means is basically people from the West who come from either the United States, Canada, or somewhere in Europe. And if you actually look through the repositories of psychology literature, one finds estimates of between 70 and 80% of all literature that is conducted in psychology right now is conducted on these types of participants. And it raises the questions of whether many of the findings that we tend to see in psychology actually generalize to all human beings on this planet. Finally, we have internal validity, and this is a study's ability to rule out alternative explanations for a causal relationship between two variables. And this type of validity only applies to experimental context. Before going on to talk about the claims, let's talk about some types of errors in reasoning. So probably the two most common that get talked about, these are mentioned both in your book and will come up a lot in statistical lectures as well, are type 1 and type 2 errors. So type 1 errors are when we make a claim about the world or a population that some phenomena or trait or behavior or relationship is present, when in fact those are not, or they're not actually reflected in the world. This would be an example of false positives. So this would be if I went to the doctor and they gave me a cancer screening and then they told me I had cancer, when in fact I was completely healthy. Now, type 2 errors are the opposite. This is when we make a claim that a certain phenomena or trait or behavior is not actually present in the world, when in fact it is. And this would be an example of a false negative. So using that cancer screening example, this is if I went into the doctor, got a cancer screening, they told me I was totally healthy, when in fact I had cancer. Now, in psychology in particular, people tend to be very scared of making type 1 errors and less so about type 2 errors. And I mean, I suppose that's understandable because you look kind of like a goof if you make a big claim and then it turns out that that's not in fact the case. Whereas if you're the other way around and you don't actually report something, then chances are nobody really heard about it, because if it wasn't sort of significant, chances are it wasn't published until, well, recently, and so no one actually heard about it and no one talked about it. Now, that's fine and well and dandy when it comes to our own sort of like personal image, is how we are as researchers, but at the end of the day, it is important to acknowledge that both types of errors are always possible because of the probabilistic nature of how we do research and try and grapple with the complexities of the world. There is nothing you can do to completely remove the possibility of making these two types of errors. And when we're talking about moving an entire field of literature forward, it is important to be able to recognize and acknowledge the presence of these errors without vilifying people who make them, because when you do so, it will make people less likely to report on such errors, which makes them more likely to persevere through the literature, hampering all of our collective knowledge. Now, two types of additional errors that are not covered in this textbook that I'm putting here just so that you are aware that they are present are type 3 and type 4 errors. So a type 3 error is when we arrive at the correct answer, but our models or questions are in fact incorrect. So an example of this would be if you conclude that there are systematic differences between the homeless population and non-homeless populations. So this would be appropriate because in fact there are systematic differences that exist between these two populations. But now if you conclude that this is because of individual personality traits that are different between homeless and non-homeless people, like for example you say that non-homeless people are more conscientious than homeless ones, there is a fundamental difference in these populations, but it is not for this reason. Rather, a much more effective model to explain the differences between these two populations would be that there are systematic factors around the two populations that govern the differences in these two populations. So here we have a correct difference that is observed. It is reflected in the world itself, but our explanations for why that in fact is the case are incorrect. Now, type 4 errors are a little bit stranger even still, and this is when we arrive at the wrong answer even though our model is correct. Now, this can happen a lot actually, even though it seems like something that would be obvious and thus easy to avoid, but it tends to happen a lot when we're dealing either with multivariable or multi-level experimental designs, and especially when we are trying to interpret statistical interactions. Now, if you would like to have more information on either of these two, you are welcome to stop by office hours, but I feel like if I carry on too far in trying to explain these two types of errors in the context in which they happen, we'll get so far afield that I will forget why I originally started this lecture. So, coming all the way back around, applying the validities to frequency claims. So please remember that frequency claims are usually asserting that some number or proportion of a population has either a trait of or a behavior of some kind. Now, when it comes to these types of claims, you can apply or ask about construct, external, and statistical validity. So construct validity, please remember, is just how well our measures and tools accurately are able to measure the phenomena that we're after. So if I'm interested in looking at the number of people across this entire continent who still smoke cigarettes, well, then the way in which I ask that will make a difference. If I just sit at a coffee shop and watch people who are smoking versus I call people in my local neighborhood versus I have a national anonymous survey poll that goes and asks people whether they still smoke or not. Not all of those metrics are equivalent when it comes to having a high degree of construct validity, with the representative sample across the entire country having the highest degree of construct validity. We can also ask about external validity. If I am only asking people at a bar where they are actually ashtrays outside about how many of them smoke, that probably is not a very highly externally valid representative sample if I'm looking at all people in the world, because not everybody goes to a bar where there are cigarette trays outside. Finally, statistical validity, this will apply to this in terms of how well the conclusions are supported with the statistics that were used on that particular type of claim. In order to truly evaluate this, you should spend some time familiarizing yourself with the specific statistical tests that can get conducted with this type of research. That being said, chances are if you actually go into a career in which you do research, you will automatically become familiar with the statistical methods associated with the types of claims and methodologies that you use the most. You don't have to remember all of them, but be aware that it is good to be able to look them up, and when you do look them up, that you should have enough background knowledge in statistics to be able to make sense of what that textbook is saying to you. It is not appropriate, however, to ask about internal validity. Because remember, internal validity is how well can we rule out alternative explanations for a causal relationship. Here, we are only looking at a single variable and looking and examining at how often it takes place or occurs. There is no causal attribution here. We're not saying one thing causes another. All we're saying is there are this many smokers. We're not talking about whether smokers tend to enjoy eating barbecue or whether barbecue made them become smokers. Not talking about anything like that, just how many smokers there are. Going on to association claims, this is very similar to the frequency claims, so please recall that association claims are usually about asserting that either two or more variables are related in some manner, that is, there's a correlation between them or they covary. For such claims, it is also appropriate to ask about construct, external, and statistical validity. So construct validity again, right? How well did we measure the things that we're talking about? External validity, how well did the findings from this particular study generalize to other contexts where I could hypothetically repeat that study? And statistical validity, again, here just be very mindful because you can have significance metrics around correlations along with effect sizes, so it is good to be familiar with both when you were thinking about how they did these types of tests. Another thing that's important to mention here is overwhelmingly all of the statistics that you were likely to be taught over the course of your time here at this institution fall under what are called parametric statistics. One of the assumptions of parametric statistics are that the underlying data distributions are Gaussian or normally distributed, even though not all data types exist in the world that are in fact Gaussian or normally distributed. When we come across these, we actually use an entirely different set of tests which fall under the family of non-parametric statistical testing. Another part of having a high degree of knowledge around statistical validity or being able to critique something on that basis is knowing when appropriate tests were actually used based on the method and the data that you have. This is an unbelievably common error that actually takes place, and statistical consultants rake in a tremendous amount of money simply being able to tell other people that the data that they have is either inappropriate for the questions that they're asking or what questions they can actually answer from the data they already have. Just like last time, it is not appropriate to ask about internal validity here because all we're talking about is a relationship between two things, not a causal link from one to another. Finally, there are causal claims. So causal claims are usually asserting that two variables are not only related, but that one of those variables actually causes the other variable. Now, all four forms of validity can be applied to these types of claims, but before you get there, there are three things that need to happen. They must be present in order for a causal claim to be made. If these things are missing or not provided, that causal claim is not standing on strong ground. The first is covariance. This is just a statistical way of saying that something is related, that they vary together, or variance knowledge on one can be used to explain the variance of another. If two things are not related, if they do not covary, it is impossible for them to be causally linked, because if something happens that causes something else to happen, they must be related, because every time the cause happens, the effect probably happens too, and the effect cannot happen without the cause. That relates to temporal precedence, and this is that there needs to be the correct sequence in time. You cannot have an effect that happens before the cause. That is just impossible. It doesn't work like this. So if that correct temporal sequence is not provided, there can be no causal claim. Now again, this is one of those things that sounds like it should be unbelievably obvious, but it is amazing how often this type of error actually creeps in. Finally, high internal validity. So along with asking about construct validity, statistical validity, and external validity, we can now ask about internal validity. And this is how well can we rule out alternative or other possible explanations for why a cause and effect relationship exists. If we cannot rule out alternative explanations, then it becomes really hard to actually make this cause and effect claim. For example, if I go back to this idea of I'm giving people coffee and decaf to test the effects of caffeine on reaction time, and I find out that people who drank the coffee actually were faster than people who drank decaf, sounds great. But now what if the people who I gave the caffeine coffee to had cold coffee, and the people I gave decaf to, it was just piping hot? And perhaps that cold coffee just was so much nicer on the hot day that we were doing this experiment that those feelings of positivity are actually what made people perform faster than having to drink a really hot drink on a very hot day. In such a case, even though it might seem intuitive to us that it's caffeine that's changing their behavior, in such an experiment, there is no way to rule out between these two differences. This would be what we call a confound. In this case, the internal validity would be low because we cannot rule out one explanation from the other. In order to have causal claims, there must be a high degree of internal validity. Now, it is probably difficult to always have unbelievably high internal validity, depending on the context also, but the higher the better when it comes to making causal claims. It should also be noted here that especially, well, really only in experiments, there's often a delicate and fine balance between internal and external validity. Oftentimes, the higher you make your internal validity, the more and more you will control and curate that context, and this will tend to decrease its external validity because by creating such a controlled and artificial environment, that environment is not oftentimes reflected in the world at large, and this can be a conflict. Now, please note that no one study must be or has to be conducted that has very high validity across the board, because this is oftentimes impossible. A better way of approaching this is actually to run multiple studies, each of which has a sort of high degree of one form of the validity that the other forms are lacking in, and this allows you to have sort of a multi-pronged approach, allowing you to make up for all different types of weaknesses. Another thing just to keep in mind, temporal precedence and internal validity are something that is evaluated methodologically, meaning you can just look at a method section and establish whether these things are actually present or not. One does not actually have to look into the results section to be able to apply these two types of things.